Gift, how are you? Yeah, thank you.
Oh no. Oh no. Yes, baby.
Hello and welcome to another very wonderful class in physics. So we all know this is the platform we are using, Tclassified.com, and I'm going to quickly head to all courses. I'm going to be opening the physics so that we can start immediately. Yes, I hope we all know that we barely have 2 weeks to the exams. The JAMB exam is still starting on 19th. The date is sacrosanct. They are not going to change the date. So you have to work towards that date, 19th of June, this very month, 19th of June, okay? So I'm going to scroll down so you can see the various subjects that we have. Today we're going to be having physics, so I'm going to scroll down to physics so that we can have, this is the physics we are using, the one by Zemoza. Okay. Okay, so I'm going to scroll down. So we looked at most of these topics already. Alima, you people are making noise. You can use the classroom. Okay. So I'm going to scroll down. You can see the various topics we've looked at so far. Abraham, what does he want? He can talk to you now. Okay. Abraham, have you been able to upload it?
Yes, sir.
Okay. So I'm going to go down to physics roundup. That's what we're going to be having today. So I'm going to click on it. So this physics roundup is basically a summary of what we are supposed to know. And it's going to involve solving past questions. And from these past questions, we're able to touch several topics that you're supposed to be good with before your exams. Okay, so let's start. The first question says, a dam is able to hold a large quantity of water because its wall is A, thickest at the top, B, thickest at the middle, C, thickest at the bottom, D, the same thickness all through. Okay, Brown. Okay, so how are we going to handle this problem? Now you have a dam. This is normally how a dam is. I don't know how to, okay, this is how a dam is. So the top is very small. The thickness expands as it gets down. And that's why it's able to hold large amounts of water. If you look at dam, you can just Google the shape of a dam, and you're going to find out that this is actually how a dam looks. So every dam is thickest at the bottom. That's where you have the largest thickness for the dam, thickest at the bottom. And that's why the dam is able to withstand heavy flow of water and large quantity of water. Okay, so with that, this question, a dam is able to hold a large quantity of water because its wall is, so the answer is thickest at the bottom. Like I said, this is the shape of a dam. It starts small at the top and it extends to be very big at the bottom. It has the thickest width at the bottom. So you can see from the explanation to this question, you see water pressure increases proportionally with depth. So the pressure exerted by water is more down. So if you don't want your dam to fall, you have to make sure that down the bottom, the thickness is very large so that it can withstand the force of the pressure down, because the more the depth, the bigger the pressure. That means the deeper you go, the more forwards, the more the pressure. So the thickness helps to support the maximum pressure at the maximum depth, which is the bottom. So at the bottom, we have what we call the maximum depth. So in order for the dam to withstand such maximum pressure at the maximum depth, the bottom has to be extensively very, very big, thick. So the answer there is option C. So take notes. Okay, just a little bit. Some of my students did not get the link, so I'm gonna reshare it. Wow, I didn't share the link. Yeah, just a minute. I want to share the link. Okay. So, Abraham, is it complete now? Okay, you're still posting. I should refresh now. Yeah, Blessing, how are you? Blessing, how are you?
Fine, sir. Good evening, sir.
Okay, I didn't remember I didn't share the link on the WhatsApp group. I had started the class already.
Yes,
I
sir.
just found somebody chatted me up privately and asked whether I'm not going to share the link today. That's when I knew I did not share it. But I believe it's on the group now. You guys can see the link now, Abi?
Yes, sir.
Okay, so I'm going to wait a little so that every other person will join up before we start. Oluwase, how are you?
Fine, sir. Good evening, sir.
Okay. I was telling Blessing, I didn't remember that, I didn't know that I didn't share the links on the WhatsApp groups. I already started the class. Then somebody chatted me up privately and asked me whether we are not going to have class today. Then I remembered I didn't share it. But we're here now. So I'm going to give, because for sharing the link late, I'm going to give just 2 minutes more so that we'll see whether everybody joins up. Okay, so we're going to start now while they join up. So the first question we're looking at, today we're going to be looking at a variety of physics questions. And from one question, I'm going to be explaining a whole lot of things. So we'll look at a specific question, then I'll explain all the concepts surrounding that very question so that we'll understand them in case if we'll see similar questions to them in the exams. And the number one question we're going to be looking at is a dam. We're going to understand how a dam is built and the basic principles that are considered in building a dam. And the question goes, a dam is able to hold a large quantity of water because its wall is, we have A, thickest at the top, B, thickest at the middle, C, thickest at the bottom, D, of the same thickness. So when you have a dam, how is a dam built? What are the things considered in building a dam? Now, I want you to know that this is the shape of a dam. See the way my hand is? So this is how a dam is. Dam is what we have in Kenji Dam, in Shirodo Dam. You use dam to generate electricity. So what basically happens is that in a dam, you have a turbine. As the water is flowing past the turbine, it's turning the turbine, and by the turning, it's able to turn a motor that generates electricity. So this very dam that I say that looks this way, it looks like this. This is the shape of a dam. This is the shape. So it's very small at the up. Then as it gets down, it gets very thick. And why is it that the scientists or the engineer that built the dam, why is it that they build it in this form? If you use your phone and browse shape of a dam or just browse dam and click on images, you're going to see that this is how a dam looks. So it's smallest, the thickness is smallest at the top, but biggest at down. Why? Because water pressure increases with depth. The pressure exerted by water on the walls of the dam is biggest at the bottom. The more the depth, the more the bigger the pressure. So it is expected that you have more thickness at the bottom in order to withstand the force. There's more force of water at the bottom than it is at the top. And that's why the thickness is biggest or is largest at the bottom. So with this explanation, we can see that option C, which is thickest at the bottom, that's the right answer. And in order to explain this, we have water pressure increases proportionally with depth. That means the more the depth, the stronger the force of water, which is called pressure. It is more down. So the more you go down, the more you feel the force of the water, called pressure. And that's why we say water pressure increases proportionally with depth. So the thickness helps to support the maximum pressure at the maximum depth, which is the bottom. So take note. So we can understand three different things from this very question. Number one, we should be able to understand that water pressure increases proportionally with depth. So you're going to be asked something like that. Water pressure increases proportionally with depth. Then number two, we need to understand the shape of a dam. And like I told you, this is the shape of a dam. A dam, you have the walls, concrete walls. A dam is concrete walls. So the concrete walls is, the thickness is smallest up, but gets bigger as it gets down. Okay, let's look at another question. And this says, a body of mass M moving round a circle of radius R with a uniform speed V experiences a centripetal force F. The work done by the centripetal force on it is given as what? Is it A, F, V? Is it B, 0? Is it C, FMR? Or is it D, FR over M? So I expect you to be jotting this down on your exercise book so that you can always go through them, read them, understand them, and move forward. But in case if you're not jotting down, that means you should be able to get back to this our platform, Educate Africans, and look them up. So everything we are doing, the lesson is under physics roundup. If you open the physics, you will see the last thing posted here, physics roundup. And like I said, in this physics roundup, we are taking a look at all plenty problems and we are sorting them out. And that is how we are going to be learning henceforth, so that I'll be able to cover all the remaining past questions. So as I'm explaining it, I'm also explaining the concepts to you so that you understand the concepts, the answers, and you're getting ready for your exams. Like I said, your date for your exams is sacrosanct. They are not going to be changing it. It's 19th. You have barely 2 weeks to the exams, and you need to focus, give your education maximum attention at this very time so that you'll be able to write the JAMB once and for all. And that is why, in order for us to maximize the little time we have, we are going to focus more on past questions so that as you are seeing them, you are seeing different ways of solving this problem. Okay, in the solution here, we have centripetal force is always towards the center of the circular path. And it is responsible to restrict the particle to move in a circle and not responsible for the displacement of the particle. So it restricts the particle movement in a circle and not its displacement. So the work done by the centripetal force is 0. It's always 0 because when you're talking about work done, we're talking about moving a distance. So if no distance is moved, if it is still rotating round that very circle, no distance is moved out. That means the distance part of the work done is 0. So you multiply it with the force, it gives you 0 as well. So the next question says, the block is acted upon by 2 horizontal forces. So you can see the 2 horizontal forces. One is 1 Newton. The other one is 10 Newtons. So the block is acted upon by 2 horizontal forces as illustrated in the diagram above. So the block accelerates at 1.5 meters per second squared. Calculate the mass of the block. So what is the mass of the block? Now, the solution, we know that force is equal to mass times acceleration. Now, what is the resultant? Who can tell me this arrangement in this force of 1 Newton? Who can tell me what this force of 1 Newton is? Who can help us?
Frictional force.
Frictional force, Oluwaseyi, very brilliant. Frictional force. That force that opposes the motion, the normal motion. Somebody is dragging this block with a force of 10 Newton in one direction. Now you have another force that is trying to oppose the motion. So that force that is always trying to oppose the motion, you can see is in opposite direction to the 10 Newton. That force is known as frictional force. Chika, that force is known as what? Chika, that force is known as what? Chika, are you paying attention at all? Samuel, that force that is opposing the motion of the 10 Newtons force is known as what?
Frictional force.
Frictional force, good. So now, if frictional force is taking part of that force, so that means that the resultant force is simply that force of 10 Newton minus the force of 1 Newton. So that is the resultant force. So the resultant force here is 10 minus 1. This one minus this one. If you want to know the net force that is actually pulling it, so it becomes 9. So substitute 9 inside this into this very equation, F equal to ma. We're going to find out that F is 9, which is the force, equal to ma. M is what you're told to calculate, and A is acceleration due to gravity, and is given here as 1.5. So make M the subject of the formula. You have M equal to 9 over 1.5, which gives you 6 kg, and that makes option A the right answer. Samuel, is it clear?
Yeah, absolutely.
Okay. Samuel, what about the explanation I gave for the dam? Is it clear?
I was having network issues, so
Okay, you were having network issue. So what I explained was that a dam is built like this. This is how a dam is built. Dam is that concrete wall that is built inside a stream or a river.
Okay.
That you can use in generating electricity. So it's normally built like this because down is where you have more pressure. The water is that much pressure. The more the depth, the more the pressure. So the thickness at the bottom is maximum. And it's a normal question in both JAMB and WAEC. So take note of that. Are we clear on that?
Okay. Yes, sir.
Okay. So another thing is that a work done in a centripetal force is normally 0 because it's not actually moving out. It's not moving out. The centripetal force is restricting the motion of the circle in a constant circular movement. So we've looked at those two. So let's move on. Which of the following quantities are dimensionally independent? So when we talk about which of the following quantities are dimensionally independent? So we have dielectric constant. We have momentum. We have efficiency, and we have refractive index. So we have option A, 1 and 2. So 1 and 2 is dielectric constant and momentum. We have option B, 2, 3, and 4. 2 is momentum, 3 is efficiency, 4 is refractive index. Then we have C, 1, 2, 3, and 4. 1 is dielectric constant, 2 is momentum, 3 is efficiency, 4 is refractive index. Then D is 1, 3, and 5. 1 is dielectric constant, 3 is efficiency, 4 is refractive index. Okay, so which of them is dimensionally independent? Who can tell me what dimensionally independent means?
It's the opposite of derived dimension. That means it's not derived from any quantity.
Good. The ones that are not derived. So the ones that are dimensionally independent are mostly the fundamental quantities of length, mass, and what? Who can tell me length, mass, and what?
Time.
Time. Good. So they are the basic one. They are always dimensionally independent, whereas the derived quantities are dimensionally dependent. But these other ones that you have, all these other constants, they are also dimensionally independent, just like the fundamental quantities. So dielectric constant is a constant. Efficiency is also a ratio. Refractive index is a ratio. So three of them are not dimensionally dependent. But momentum can be gotten. Momentum is mv, mass times velocity. So velocity is still a dependent, a derived quantity. So it cannot be there. But these other constants are there. Dielectric constants, efficiency, refractive index, and other fundamental quantities like mass, length, time, all of them are dimensionally independent. So that makes D the right answer. Chika, did you understand this? This one is a little
Yes,
bit
I
tricky.
did.
Okay, it's a little bit tricky, but you have to understand it this way. Whenever you hear dimensionally independent, we are talking about the fundamental quantities. But in this case, there is no fundamental quantity given here. But you know that this other one, the electric constant, efficiency, and refractive index, they are not derived quantities. They are actually ratios and constants. So they are also dimensionally independent, just like the fundamental quantity. But when they tell you dimensionally dependent, it means that they are the derived quantities or derived dimension. And you can see here I said momentum cannot be dimensionally independent because it is dependent of momentum is equal to mass times velocity, mv. And these two quantities, mass is a fundamental quantity, but velocity is a derived quantity of length over time. So this cannot be independent, they are dependent. So that makes it not, it shouldn't be among the options, but I, and IV, which is option D, is the right answer. So you can see from this lesson, you're able to know what fundamental quantities are, what derived quantities are, and what ratios and constants are. So simple way of covering everything. We know that we have two major types of quantities. We have derived and fundamental quantities. We also have what we call the scalar and the vector quantities. We say that the scalar quantities are those quantities that have magnitude but no direction. Whereas vector quantities are those quantities with both magnitude and directions. Okay, so let's move forward. So we have this projectile motion problem. And it says, a body is projected with an initial velocity, u, at angle theta to the horizontal. If R max, which is the maximum range of the projectile, if R max is the maximum range of the projectile, what does the relation squared over R max represent? What does the relation U squared over R max represent? If you followed our classes when we started, you realize that we learned projectile motion and we gave the various equations for the projectile motion. The equation for time of flight, equation for time to reach the maximum height, equation for maximum height, equation for range, and equation for maximum range. So we're going to find out what R max represents. Okay, so option A is the vertical distance covered, vertical distance. You know that vertical distance is the height. Range is the horizontal distance, so take note. B, acceleration due to gravity. C, the horizontal distance covered. D, the acceleration of the body. Okay. So R max is the maximum displacement, maximum horizontal displacement. But the relation they are telling us to find out is U squared over R max. Okay. So solution, R max is equal to U squared over G. Make G the subject of the formula. If If you make G the subject, G becomes equal to U squared over R max. So the answer is simply D, because G, this very representation, U squared over R max, is simply equal to G. Because from here, you see that R max is equal to U squared over G. So if you make G the subject, G becomes equal to U squared over R max. So that makes option D, the acceleration due to gravity, as the answer. But take note, this is the relation that they told you to find what it represents. They did not tell you to find R max. If they had told you to find R max is the horizontal distance covered. But you are told to find U squared over R max, which you can only know if you know the relationship between R and G. And this is the general relationship. But at maximum height, where theta becomes equal to 45, you can now have that sine 2 theta becomes sine 2 times 45, and 2 times 45 is 90. Sine 90 is 1, and it becomes U squared over G. And it is this R max is equal to U squared over G. That's where we got, if we make G the subject, you have G equal to U squared over R max. That's how we got this very relation. And that's how we got to know that G is what is being represented. But take note, this is the formula for maximum range. Chika, is this clear?
Yes, sir.
Luase, is it clear?
Yes, sir.
Blessing, are we making sense? Blessing, are we making sense? Okay, Blessing can't hear us. Let's continue. Okay, the next question says, an object at rest is said to possess what kind of energy does an object at rest possess? Is it potential energy, kinetic energy, chemical energy, or electrical energy? Oluwase, help us with that.
Potential energy.
Potential energy. A body at rest possesses potential energy due to its position. Kinetic energy is for energy of objects in motion. Electrical energy is the energy exerted by the movement of electrons, whereas chemical energy are the energy in substances. So you should take note of these various forms of energy. To be potential, that energy that an object possesses because is at this height, is at rest at this height, potential energy. Kinetic energy, energy possessed due to motion. So take note. So you see, we've looked at forms of energy. So let's look at the next one. According to Newton's law of cooling, the heat energy loss per unit area of the body depends on what? So you're automatically learning the factors on which the heat energy lost per unit area of a body depends. What are those factors that heat energy loss during cooling depends? Looking at Newton's law, what are those factors? Is it surface area? Is it nature of the surface? Is it temperature of the surface? Is this excess temperature over the surrounding? So what are the factors on which energy loss per unit area of a body depends on? So those factors are: 1, the surface area; 2, the nature of the surface; and 3, the temperature of the surface. Those are the 3 factors that the energy loss per unit area depends on. Luashe, are we clear on that? Luashe, are we clear on that?
Yes, sir.
Okay. So if you are asked the three factors on which the energy loss per unit area of a body depends on during cooling, you can state them. Okay, let's move forward. The graph above or the graph below, the graph of density against temperature for water is correctly illustrated by, is it option A, B, C, or D? Leonard, please come. Please help me and buy something that is very cool. Maybe Coke. Very, very. So who knows about the anomalous expansion of water or the anomalous behavior of water? Who knows?
I think it's animals expansion of water depends on the temperature of, like, when the temperature goes from 4 to 0 degrees. When the, like it contracts based on the temperature.
Yeah, good one. Good attempt. Who can help us further? Who can help us further? So Chika, are you paying attention? Chika, are you there? Luashe, are you there?
Yes, sir.
Okay, I want to explain what the anomalous expansion of water is. Anomalous expansion of water is a special behavior of water. And in this very behavior of water, it is supposed that as the temperature is increasing, density is supposed to be decreasing. That's the normal behavior. As the temperature is increasing, density is supposed to be decreasing. But for water, from temperatures of 0 to 4, instead of the density decreasing as the temperature is increasing, the density will be increasing. So you can see it here from 0 to 4. As the temperature was increasing, the density was also increasing. But immediately after 4, it starts behaving normally. So this is the way it should be. It should be that as the temperature is increasing, the density is decreasing. But from 0 to 4, as the temperature was increasing, density was increasing as well. But once it gets to 4, it starts behaving normally. So that behavior from 0 to 4 is known as the anomalous expansion of water. It is expanding, it is doing the wrong thing instead of doing what it should do. Luashe, do you understand this?
Yes, sir. Increasing based on.
Okay, so that is what we call the anomalous expansion of water, and it's rightly represented by option C. So let's move forward. Okay, Abraham, I should refresh, man.
Yes, sir.
You have more than 13 already there. Okay, so I'm going to refresh because we are just feeding in all these questions. So I'm teaching you, we are loading it. Okay. So let's look at the next question. And it says, a football is kicked at an angle of 45. So you kick a football at an angle of 45. This 45, 90, 45. 0, 45. Angle of 45 to the horizontal over a distant line up with a velocity of 15 meters per second. Calculate the magnitude of the horizontal velocity of the ball at the highest point. So we need the horizontal component of the velocity at the highest point. And it says neglect friction and take the acceleration due to the gravity to be equal to 10 meters per second square. We have option A 0.0, B 5.6, C 10.6, and D 15.0 meters per second. Okay, solution, you can see this is the man here. They are kicked this ball at an angle of 45. You can see the way the illustration is done. And this ball was kicked with a velocity of 15 meters per second. So at this very point, you are supposed to calculate the horizontal component of this velocity. So vertical component of the velocity Vy is equal to u sine theta, whereas the horizontal component of this velocity is u cos theta. And theta is 45, cos 45 is 0.707. So u cos theta is going to be 15 times 0.707, making it 10.61 meter per second. And that's option C. So make sure you're writing. If you're not writing after the class, just go to the platform educateafricans.com and take down your notes. So let's move forward. Rainbow formation is a natural phenomenon illustrating that white light does what? Rainbow formation is a natural phenomenon. What property of or what exhibition of light does the rainbow formation explain? So A, is it that light splits into 3 components after rainfall? Is that what rainbow shows? Or B, it dispersed by glass prism? Or C, light splits into its constituent colors before rainfall? Or D, light is dispersed into its constituent color by raindrops? So what's the whole essence of rainbow formation as regards to your lesson in light? So who can tell us? Rainbow. What does rainbow show? What property of light does rainbow show? Chika, can you look at the solution and tell us what rainbow shows?
So it shows the dispersion of.
So rainbow, anytime you hear about rainbow, like I said, as we are explaining these very questions one by one, you're supposed to carry the knowledge and infer other questions that are similar to that. So next question could be, what is a rainbow? What is rainbow? So you should know what rainbow is. So rainbow is the dispersion of white light into its constituent colors by raindrops. That's actually how rainbow is formed. When you see that rainbow, some people will see rainbow, they will think maybe it's God that just brought out the rainbow. Some will think that it's magic. Some will say it's the rain that, because rain wants to fall, that rainbow will always come out. But you as a physics student, you're supposed to know that rainbow actually occurs whenever there is dispersion of light. When light hits the raindrop, it disperses and separates it into its different colors. So you now see those different 7 colors of rainbow is actually caused by dispersion of light. The white light, once white light hits raindrop, it is dispersed into the various colors of the rainbow. Oluwaseyi, are we clear on that?
Yes, sir.
Okay, so let's move forward. So you can see now we've touched light. Now let's move more further into light. Now question number 22 says, the lens illustrated can best be described as a what? So this lens that is looking like this, what kind of lens is that? What kind of lens? So whenever you see a lens, you have one side that is plane and the other side is curved. It is normally called plano. So if it is like this, we call it plano convex. But if it is like this, we call it plano concave. So one side is plane, one side is the curve. So this is a what we call plano convex. So the question says the lens illustrated can best be described as, is this a converging meniscus? Is it a plano convex lens? Is this a divergent meniscus, or is this a biconvex? So in order to explain this very question, I could have told you that the answer is plano convex, but went on to draw the different types of lens. So from this explanation, even if you've not read this topic before, you're supposed to have that you're supposed to know that we have different types of lenses, that we have the biconvex lens, and this is how it is drawn. This is biconvex, double convex, there is no plane. This is plano convex, that means one side is plane and the other side is convex. This is concavo convex, that's converging and also convex. This is biconcave, biconcave. This is plano concave, one plane, one concave. And this is convexo concave. So take note of these various types of lens. So this question can come in another form. They can ask you, which of the following is not a type of lens? So by now you know all the different types of lens. So any other thing that is brought in, you should be able to say, no, this is not a type of lens. So this biconvex here, this is how it is drawn. This is biconcave, plano concave, plano convex, concavo convex, and convex concave. So take note of these various types of lenses. Okay, let's move forward. Okay, so you can see that we've been dealing more with light. In case if you did not do much on light, we're using this opportunity to dig deeper into light. So the next question says, two plane mirrors are inclined to each other so that the object placed between them has 11 images. Two plane mirrors are inclined to each other so that the object placed between them has 11 images. Determine the angle of inclination. Is it A 30, B 45, C 60, B 90? Now, the formula for this is N equal to 360 over the angle of inclination minus 1. So N represents the number of images. Theta represents the angle of inclination. So you're told to calculate the angle of, determine the angle of inclination. So you have to make theta the subject. But because you already know that N, the number of images is 11, so you take this one to this side. So it's minus here, coming over here becomes plus. So 11 plus 1 is 12. We have 12 here. So 12 becomes equal to 360 over theta. So make theta the subject. So theta equals to 360 over 12, which is 30. That makes option A the right answer. Chick, are we clear on that?
Yes, sir.
Okay, let's move forward. We're almost running out of time. But everybody can see, all these are on our platform, Educate Africans. Quickly go there, even if we didn't finish this. And our subsequent classes, we are going to be looking at full past questions, one year. Look at 20 days, we look at, so that we can use it to cover a whole lot very fast. That's what we're going to be doing mostly. Okay. Question 24 says the pitch of a note is not affected by what? So you're supposed to know what the pitch depends on and what it does not depend on. So they're asking us, give us one thing that the pitch is not dependent on. Is it the frequency? Is it the tension in the vibrating string? Is it the mass of the vibrating string? Or is it the amplitude of the sound? So the pitch, take note, the pitch is never dependent on the amplitude of the sound. So what is pitch? You see, apart from knowing what it depends on or what it does not depend on, we are also able to learn what a pitch is from this. So what is a pitch? Pitch of a note is its position on the musical scale. With a pitch, you can differentiate between a high and a low note. And it basically depends on the frequency of sound. So pitch depends on frequency, take note. But the loudness depends on amplitude. Loudness is what depends on amplitude. Okay, let's go to the next question. When a flat plate conductors are arranged in such a way that they possess equal and opposite charge dielectric, they form what? What kind of device do they form? When you have flat plate conductors arranged in such a way that they possess equal and opposite charge separated by a dielectric, what kind of appliance do they form? Is it electroscope A? Is it electrophorus B? Is it C, capacitor? Or is it the cell? So in order for us to understand this, we need to know what is electrophorus and the rest. Electroscope. So you can see here, electroscope is an instrument used for the detection and testing of small electric charges. So from this, you can see what electroscope is. Any instrument that can be used to dictate and test very small amounts of electric charge is known as electroscope. Now, what is a capacitor? A capacitor is used in storing charges. We already know that. And a cell is used in supplying voltage. Now, what is electrophorus? Electrophorus is a device for transferring and storing charges. It produces electric charges by induction. So any device that you can use in transferring and storing charges is known as electrophorus, and they produce electric charges by induction. So from these, two flat plate conductors arranged in such a way that they possess equal and opposite charge and are separated by dielectric. What is that? It's a capacitor. So take note. Let's move to the next question. So we have this diagram. You have this north, south, and this kind of diagram. And you're asked, which electrical device does the diagram above illustrate? Is it an AC generator? Is it an AC motor? Is it a DC generator or a DC motor? Now, this is a typical diagram of an AC generator, and you can see that it resembles this. So whenever you have a slip ring, this slip ring, know that we are talking about an AC generator. But when you have a split ring, know that we're talking about a DC. So this is AC generator. But once you change this very slip ring to split ring, then it becomes a DC. So you're going to have, if you're drawing a DC, it's going to be almost the same sketch as this. But just know that this place where we have the slip ring for AC, for DC it is split ring. And take note, you're always going to have this magnet, North Pole and South Pole here, just the way we have here. And you're going to have the armature. This is known as the armature. And you're going to have the mechanical device here. Then you have your carbon brushes that connect the slip ring. And you have the external circuit that is supplying voltage. So this is a basic generator. Once you change this slip ring with split ring, then it becomes a DC generator. So note, a generator is simply when you have these bars of magnets, you have your armature that you're able to rotate using a mechanical device. Then you have either slip ring or split ring. If it is slip ring, then it's an AC generator. If it is split ring, then it's a DC generator. Are we clear on that? Chick, are we clear?
Yes, sir.
You remember in the last class, we learned about transformers. Now we are learning about generators. These are generators. So you can either have an AC, that's a generator that supplies alternating current, then, or you have a DC generator, that means a generator that supplies direct current. So the basic difference is that in an AC, we have slip ring, whereas in a DC, we have split ring. So take note, it can come in, they can ask you this question, that they can ask you the difference between AC and DC is simply changing the slip ring to split ring. So that is where the question is, and that's why I'm emphasizing on it. And like I told you, from one single question, be able to look at what we can see in other questions. Okay, let's keep going. Please, we're already time for us to start our government, but I'm going to keep going because I want us to cover more since we started. Okay, so let's look at this question. A wire of length 400 cm is stretched between two fixed points. So you can see the two fixed points, this point and this point, and the wire is 400 cm. Now, when plugged, its fundamental frequency is 150 Hz. Once you plug it, the fundamental frequency is 150 Hz. Now, calculate the speed of the wave produced. So calculate the speed of the wave. So if this is the total length, you can see the total length. So make sure you know that F is always equal to V, velocity over 2L. Supposed to be velocity over lambda. You know that frequency is equal to V over lambda. But we see that lambda is equal to 2L. So in place of lambda, we'll put 2L. So make V the subject. V is equal to F times 2L. So sort it out. F is what? 150. Frequency is 150. Then 2 times L is 400 cm. Convert it to meter, it becomes 4. So multiply out, you have 1,200. So that becomes the answer. So always know that frequency is equal to velocity over lambda. Or I can say V is equal to F lambda. We know that formula, V is equal to F lambda. And that is what we have here. Frequency is all V over this, or say V equal to F lambda. But note that from this diagram, L is equal to lambda over 2. Okay, let's move forward. Okay, I'm going to stop here. I'm going to stop here so that we'll go down too much. And I'm going to give us an assignment now. Okay, so very quick assignment. Everybody head straight to this very our platform. So I want you guys to complete the rest of what I have, 36 down to 36 down to okay, 36 down to 50. So sort them out and send them to the WhatsApp. Sort them out, send them to the WhatsApp. As you're sorting them out, you're going to understand a whole lot because I explained them as I was solving them. Okay, so that's why we're going to be stopping. Please make sure you're studying very hard.
Okay.
Exams are almost here.
Sorry, sir.
Yeah.
Mister, can you explain how we can get this physics now? Because I checked on the website, but
You say?
how will I get this note, this physics note?
And that's what I'm saying. Now, you can get the note. Just go to internet and type Tclassified.com. Then click on all courses and go to physics. You'll see roundup physics. That's the last distance. Who is asking? What's your name? Can you tell me your name?
It's me, Samuel.
Reaching also Franklin.
No, it's
Okay,
me,
Samuel.
Samuel. Yes, sir.
Samuel, what are you joining with? I didn't see your name again. I thought you were even out.
Oh, Ada, my sister's name. I'll change it. Ada.
Okay, Ada Opera.
Yeah.
Okay. What of Samuel is okay, your name is Samuel, but you're using Ada
No.
Opera too.
Yeah, yes.
Is it your mom's line? Your mom's
No, my sister is just account that is on this Zoom.
okay. Okay, you're asking where you can get this, Abby.
Yeah, I know. I opened an Educate African account, but I don't know how to get the physics notes.
Okay, you don't know how to access this very notes on Educate Africa. If you open it, is that what you're trying to say?
Yeah, that's what I'm trying to say.
Is that?
That's what I'm trying to say. That's what I mean.
Okay, can we go through it?
Yeah, okay, I'm there. Can you hear me? Can you hear me? Hello, can you hear me?
Can we go? Yeah, Samuel.
Yeah, I mean, I'm looking at your screen.
Are you on Educate Africans now?
Yes, I am. I'm there.
Can you click on physics?
Okay. Yeah, I'm on physics.
Come.
Come on.
Using my power bank.
Your phone is dead.
Huh?
Your phone is dead.
It's very low.
Hello? Fuck me, bro. It's fucking not working. This is your phone.
You see about it's low. She needs power bank. What about your charging stuff?
Hello? Can you guys know?
Samuel.
Yes, mommy.
Yes, I'm back. My network, somebody call. Okay, Samuel, are you still there? I don't know, but I'm trying to show you how you can see this video. Once you're on Educate Africa, you click on all courses, then scroll down. Then you're going to see physics. And the physics we are using is the one by Zimozo. You can see this very physics. You click on it. So once you click on it, make sure that you're logged in. If you're not logged in, the lectures will not open. So once you click on it, you can, if you're trying to open the lectures and they're not opening, click on enroll. Enroll will be here. So once you click on enroll, you log in with what you created account with. Then you go back to opening the course. All of them will open. So if you're looking for today's class, you just scroll down to the last. You will see where we wrote physics roundup. This is what we looked at today, physics roundup. So open it up, click on it, you'll see all the solved problems. Okay. So see you when I see you. Do the assignment, submit to the WhatsApp. I want to see them. Make sure you're preparing for your exams. Your exams are almost here. Until when I see you the next time, thank you. God bless you.